Okay, so back for mini lecture 3 of the 4 for this week of October 19th to 23rd. We're thinking about sustainability in agriculture. I'm going to share my screen again. So this little mini lecture is going to be about kind of recent trends about conventional intensification, driven by things like the green revolution varieties of staple crops, other ways of sparing land. So we talked about the Borlaug hypothesis being about land sparing, right? So focus your efforts, produce a lot of food in a particular place, and when you do that through very productive agriculture, you're going to release other land, and so that it can be put to kind of natural purposes. There are other ways we could think about land sparing other than the conventional agriculture. So here's some recent data. So this is from the paper that I have here, the Kassman and Grassini paper. I'm just trying to situate my menu bar here. So the one thing is we've seen that there was this up from the about the 1960s through to 2007, 2008, we saw kind of declining or relatively stable prices overall, which implied that yield growth was outstripping population and demand growth. So prices could come down or at least stay the same. And that was the situation when we had population growth that was in the order of 1.5% per year or so, and rising to about 2.1% in 1961. And we had growth rates in agriculture that exceeded that. So we see here, you look at the 1960 to 1980 period for the wheat, rice, and maize, we saw that we had growth rates of yield increases during that time as high as 3% for maize, as high as 2.5% for rice, as high as 2% for wheat. But all of those have been coming down. So those have been coming down, which is that little inset in the left-hand diagram. At the same time, it's been essentially at the global scale, kind of linear increases year on year in yield measured in tons per hectare at the global scale. We unpack that more and look at different areas of the world that have had been produced, and a lot of research has gone into them over the last 50 years. So we look at wheat in Northern Europe, rice in California, and rice in China. So rice in China is the bottom line. Wheat in Northern Europe is the middle green line, and the upper yellow line is rice in California. All three of these just show a pattern which is pretty worrying for the future. So this is showing patterns that are as of around the year 2000 or so, or maybe a little bit later, we had a kind of a flattening of yield. So possibly kind of pushing the biological potential of these systems to increase their yields. Which means that at the global scale that they're still going up in a linear way means that that there are kind of areas which are kind of lagging behind and they're catching up still, but the front runners might be kind of more plateauing. The plateauing of yield increases is of great concern. We think about how we're going to feed the 10 billion people on planet Earth by 2050. So this is a major concern of this kind of yield effect. This shows the harvested areas. This is kind of the other side of that story. If we've had a plateauing of yield or a reduction in the rate of yield increase, then how are we increasing our food production? This shows that for these staple crops of rice, wheat, soybeans and maize, and all staple crops, sort of at the bottom area, all staple crops in red. There's been, there was a relatively slow increase in cultivated area up to about this 2007-2008 period that I've noted before in terms of the prices. And then after that, there's been a new extensification since about 2005, 2006, 2007. There's been a new push. So at the same time, we've had this more volatile prices and higher prices. Farmers individually, like farmers in Alberta here who clear bush or drain wetlands, as well as big companies who have branched into agriculture or expanded their agriculture, have been expanding agriculture into forest lands, and as I said, forest land, the marginal areas, right? So we've got this extensification or increase in land cover. So trends that we were fairly happy with in a way up till about 2007, 2008, we're not following anymore. So those last 12 years that I've been mostly here at the U of A, we've seen this new extensification at the time that the same time scientists are saying, we're losing so much biodiversity, we're contributing so much greenhouse gases as a result of land use change. At the same time as the scientists have been saying that more and more fervently, we've been losing more and more. This is a pretty remarkable kind of set of circumstances. This shows from that same article, shows in the, I have to move my bar, for the four major crops, soybeans, maize, rice, and wheat, going from left to right. In the years to 1980 to 2002, in the upper row of circles, how much of the increased production of soybeans, maize, rice, and wheat came as a result of yield increases, and how much came as a result of area increases. So we saw that soybeans, more than 2/3 in that period, more than 2/3 of the increase in soybean production was due to area increase, compared to about 1/3 for maize, 13% for rice, and 0 for wheat. So wheat was the one commodity on the planet where we had growth in production, all of which came as a result of growth in yield. The soybeans were, in a sense, the most problematic crop in terms of growth by expanding area. All of those situations changed in the most recent 2002 to 2014 period, where we now have 85% of the growth of soybean production due to area expansion, 66%, so 2/3 of the maize increase in production due to area expansion, and even wheat went from 100% all due to yield to only 83%, so 17% of the wheat increases have resulted from increase in area. So we think about wheat as often a temperate crop like we produce here in Alberta. We have places like Alberta where we have area increases as well as yield increases responsible for production increases. So these are, again, kind of which amplify what we just saw about the area increase, and we see how that kind of breaks out with sort of the global scale, and then how that breaks out into these four big crop pieces. So this is, in a sense, an alarming situation that we're in now. We're going the wrong direction. Not only we're recognizing the problems more, but we're actually going in the wrong direction. So since, people like Johan Rockström wrote about the planetary boundaries, first about 7 or 8 years ago, when Jonathan Foley first started talking about this big impact of agricultural land use on planet Earth, the problem has actually been getting worse. So, what are the options? What can we do, right, to reduce this big? So we've got a coupling. So you just come back to the first question right at the beginning of the lecture. can we decouple increase in production and increase in environmental impact? This suggests we're not decoupling, or the coupling is getting more severe since this 2002 period, especially since 2007, 2008. What can we do about it? We can look at other ways of land sparing. So this is still reducing the overall footprint of agriculture, by more efficient use of available resources that reduces waste. So there are things that are being done, for example, with precision and smart agriculture. So smart is using new information technologies to to increase yields, but also save inputs to have lighter environmental impacts. Second thing we can think about in terms of land sparing is to have radical changes in yields in places like Africa, where there are large, what we call yield gaps. And I'm going to show you yield gaps in a minute. We can also have diversification and integration of agriculture systems to make better use of available resources. So this might be something like producing 2 crops per year rather than 1 crop per year. If we can shorten the production cycle of crops from, say, 100 days to 80 days, there are places where double cropping becomes possible. It probably doesn't become possible in northern Alberta, but it does become possible perhaps in some of the Midwest in the United States. We can also intercrop, so grow 2 crops in the same field. And I'll show an example of that. And we can plant, for example, trees on field boundaries. So there are kind of a bunch of things that we can do in addition to just increasing yields. So this is a paper which shows yield gaps in different parts of the world, and ranging from the bright orange showing very high yield gaps, so very little production relative to potential production. So that's our idea. Yield gap is what's potential production, say, that you might find on an agricultural experiment station, minus actual yield. Right? And you see in places like Alberta and the Midwest of the US and Europe and many parts of China, actual production is very close to potential production. So those are showing up as green. There's not very much opportunity to expand production just by using existing technologies better. We see that there are parts, countries like Ecuador and Latin America and many parts of Africa, some parts of India and the Middle East, where we do have yield gaps remaining, Madagascar, and more can be done to produce in those areas to increase production. So that's one of our opportunities, is to figure out why are there these yield gaps and what can be done about them. And what we see is that yield gaps depend on lots of things, right? Poor access to fertilizer, poor access to information, poor access to things like irrigation or road networks, often policies like trade policies, infrastructure gaps, right? Crappy roads, and customary practices, which are and kind of risk management, which make it hard for people. So these are good possibilities going forward for the planet, but they will take real investments, and there's real challenges to address them. Think about this integrated, diverse systems of agriculture. So we have things like the farmer on the right upper corner who's planted trees, which she's now feeding the limbs to her cows. So the tree is a nitrogen fixing tree, but also produces palatable food for her cow. And then she can fertilize her tree and the other crops with manure from her field. Here's livestock grazing on crop residue in the upper left-hand corner. And again, in many places, they're encouraged to do that so that they can process the nutrients in the crop residue and make that available to the plants for the next growing season. I've got in the bottom left corner, I've got a picture of Mount Kilimanjaro in Tanzania, a place that I'm doing some work now. And you can see there the Chaga home garden system that integrates bananas and cows and tall trees and coffee in the same small production areas. And here's in the bottom left corner, another integrated system that's integrating, looks like cassava with beehives. Okay, so I'm going to stop sharing now and give you a break and then come back for the fourth and final mini lecture this time.